Hello, and welcome to this Let's Chat Bridge, our inaugural version of the Let's Chat series. My name is Karen Emmons, and I'm a board member, one of the technology event group leaders for VASO, and a national event supervisor. I'm accompanied today by Ian Evans, one of the other technology event group leaders, also a national event supervisor, and I'm sure you can tell from the name, my husband as well. This morning, we'll be covering the event Bridge. As we get going, I encourage you to put your questions in the chat and I'll keep an eye on them to make sure that Ian hears them and gets to answer them. One note before we start, in our time this morning, we cannot possibly cover every rule or situation in the rules or VASO clarifications. Nothing we say here today supersedes a rule or clarification. So please read the rules often, because every time you do, you'll see something else and then read them again. And don't forget about the VASO clarifications, which are as binding as rules. I know we have a lot of parents on today. Please remember that Science Olympiad is a hands-on activity for students and a hands-off activity for parents. Students must build all parts of the devices that they bring to the tournament. But parents, you can create a testing setup, and that's invaluable, particularly in this event, and we'll talk more about that later. Finally, this is being recorded, and we will post it on our YouTube channel and on the Bridge event page. So now I'm going to turn the microphone over to Ian.
Hey, everybody. Karen didn't explicitly mention it there, but the link right here does go to the Bridge event page on the VASO site. So today we're talking about this event Bridge, and this picture right here is a very nice example of the kind of bridge that we expect students to be building, a truss bridge, which what makes it a truss is that it's built with all of those girders in the interlocking triangles that make the bridge so strong. So this slide just gives you a really basic idea of what the event is about. A truss bridge like the one on the left, generally out of balsa wood, and then they bring it to the tournament. The bridge only, they only need to bring the bridge, and the event supervisor supplies all of the test setup that you see on the right-hand side. The students set up their bridge on the table with a bucket hanging from it, and then they pour sand in the bucket until the bridge breaks. And then when the bridge breaks, their score is computed by taking the mass of the load, which is the mass of the bucket and the sand in it, and dividing by the mass of the bridge, which is a number called structural efficiency. And the bigger that number is, the better your score, which of course means that the more sand you hold, the better your score, but also the lighter the bridge is, the better your score.
So Ian, I'm going to break in here for a moment and talk and ask about how much sand is the max, because we don't have an infinite amount of sand.
That is correct. Yes. So the maximum amount of load is 15 kilograms or 15,000 grams, and if you exceed that, you only score up to the 15,000. There are a number of caveats to the scoring. This is a simplified version of the scoring, and we'll talk more about those extra rules a little bit later on. Okay, so take a look at the picture on the left. That bridge is actually set up to be tested, and you can see that it is resting on. Sorry, I got to get my pointer there. It is resting on a pair of blocks of wood, one at each end, which we call test supports. which are on a table, and then there's a hole in the table, and then there's this block of wood in the middle of the bridge with an eye bolt through it, and then we use that to hang the bucket below the table. That block of wood in the middle is called the loading block. And on the next slide, we're going to look at a diagram of this setup, but the diagram is looking from the side on, and so just so you sort of orient yourself and get an idea of what the diagram is showing. So so here's our side-on view of that test setup. And we're going to talk about some of the key construction parameters here, which are different in Division B and Division C. Division B is the middle school students, and Division C is high school.
The elementary school students are also in Division B.
True. Yes. So so let's take a look at this diagram. At the bottom here, across the bottom, is the test base, which is their fancy name for the table. And then these diagonally slashed blocks here are the test supports that we talked about in the last picture. The bridge sits on those test supports. And then these two red things here are the loading block. When you actually test, there's only one loading block, but they're showing two because the loading block is in a different position in Division B and Division C. So let's talk about these parameters here. In Division B first, the entire bridge must be supported above the test supports before loading. So, and that's just like in this picture, the whole bridge sits on the test supports and no part of it is below the test supports. And then we say before loading because it is possible sometimes the bridges bend a little when you start putting the sand in the bucket, and that is allowed. The bridge is allowed to bend a little bit below the test supports as long as it doesn't hit the test base. But before loading, it must be all above. The second bullet there says that the loading block bottom must be at least 15 centimeters above the test supports. So what that means is that the distance from the top of the test supports to the bottom of the loading block, it's shown over here on the side is the loading block height, that must be at least 15 centimeters, which is actually pretty high. That's about 6 inches. And then the third Division B parameter here is that the clear span has to be 35 centimeters. So the clear span is the distance between the test supports. So in other words, the bridge has to be a little more than that clear span, a little more than 35 centimeters in order to be sitting on top of the test supports.
So Ian, I have another question
Yes.
here. So in Division B, the top of the distance between the bottom of the loading block and the top test supports is 15 centimeters. Does the bridge have to be the same height all the way across? So does there have to be a 15 centimeter clearance the whole way across, or is it just where the loading block goes?
It's only where the loading block goes, which is a little different from last year. The bridge, this bridge would be at least it appears to be 15 centimeters all the way across, but that's not a requirement.
It's not necessary. And the loading block though has to go in the middle.
Yes.
So that's where that 15 centimeter height is going to be expected to be.
That is correct.
All right.
Yeah. So, okay, so let's talk about Division C.
Actually, I'm going to ask one more question that's been submitted as well,
Sure.
too. So we don't have, last year there was like a pass-through block that measured the width of the bridge and the height of the bridge to make sure it was like the same and stable all the way through. We don't have any kind of device like that in measuring for this year.
There is no pass-through requirement.
All right, and we'll talk about width in a few minutes, but there's, okay, great.
Yes. So so let's talk about the Division C, the three corresponding Division C parameters here. In Division C, the entire bridge must be above the test base, not the supports, the base. So what that means is that in Division C, the bridge can actually dip down into this space here between the test supports as long as it's above the test base. And we'll actually see an example, a picture of an example like that in a few minutes. In Division C, the loading block bottom must be at most 1 centimeter above the test supports. So that's this bottom loading block here. And you'll note it says at most 1 centimeter, which means that it can actually be lower than that.
So it could be below the test support.
That is correct. It certainly could, yes. And then the third Division C parameter is that the clear span is 45 centimeters, so it's wider, longer bridge.
So Ian, are you
Yeah.
telling us then in Division C that bottom wood piece, maybe let's call it the roadway,
Yeah,
right? That can't be taller than 1 centimeter?
not exactly. And it's a little bit tricky to answer that question just from this diagram. So we'll come back to that question in just a minute.
Okay.
So I'm going to go to another slide with another diagram in a moment here that's looking at one of these test supports, but it's looking down on the test support, just so you're kind of oriented. So here we are looking down on the test support. The test support is 6 inches long in total, and then with a center line, and then there are 2 lines drawn on top of it that are 5 centimeters on either side of that center line. So the ends are 3 inches away from the center line, and the lines are 5 centimeters away from the center line. And the key thing to realize here is that in Division B, the bridge may only touch within the middle 10 centimeters. While in Division C, the bridge may only touch outside the middle 10 centimeters. So that means that in Division C, bridges are required to be quite wide. They have to be more than 10 centimeters wide, which is about 4 inches. While in Division B, bridges may not be that wide. They must touch only within the middle 10 centimeters. And they can be as narrow as you like. You have to be a little bit careful about making it too narrow, because the bridge, remember, it has to hold that loading block 15 centimeters high. So if you made your bridge too narrow, it would be very tippy.
So top heavy, you could fall
Right.
over too easily.
Correct.
What the loading block is 5 by 5, right? 5 centimeters by 5
Right.
centimeters.
Yeah, we'll talk about that a little later.
So we have a question here. I just want to confirm. It is as Ian said. So a Division B bridge may not touch in the Division C area
Correct.
at all. All of the touching has to be within that 10 centimeter space on the testing.
Right. So now that we have in mind this notion that the Division C bridges are at least 10 centimeters wide, let's jump back to this diagram and answer the question that I put off. This loading block here on the bottom, the Division C loading block, the loading block is only 5 centimeters square, but that bridge has to be at least 10 centimeters wide. Actually more than 10 centimeters wide. So that means that this loading block is not resting directly on the bottom girder that you call the roadway. It has to be resting on some structure that is built between those 2 girders on the sides. And so it could actually be a little higher than the roadway, or a little lower than the roadway, or actually, down below in this area between the test supports.
Thank you.
Okay, so now that we've got those construction parameters in mind, let's just take a look at an example Division C bridge. Actually, I'm gonna jump back here. A Division B bridge is typically going to look pretty similar to this bridge here, in that it's all above the test supports like that. That's whereas a Division C bridge, the design possibilities are broader. And this bridge, this example bridge, certainly not the only way you can do it, but it shows some of those possibilities. It actually has part of the truss above the test supports and part of the truss below the I think in this particular one, the loading block sits at that middle layer here. But you know, you could have the loading block down below. It wouldn't be legal to have the loading block on top because this bridge is higher than a centimeter above the test supports. But that just gives you some idea about what the Division C construction parameters let you do. Okay, so I told you that we would talk about the scoring in some more detail, and that's what we have here. The full formula for the score is given there. Before I just mentioned the load and the bridge mass in grams, but there's also a bonus and a multiplier, so let's talk about that. So the load is the mass of the sand and the bucket and the suspension hardware, including the loading block, in grams, and it has a maximum of 15,000. So even if you hold more than 15,000, you only get scored for that amount. And then the bonus is 5,000 grams for bridges that support the full 15,000 and 0 otherwise. So there's a strong incentive to hold the whole 15,000 grams. And then the multiplier is how we score the design log, which we're not going to talk a lot about the design log here, but don't ignore that part of the rules, because the multiplier will be 1 for a complete design log, 0.9 for an incomplete or non-compliant design log, and 0.5 if you have no design log. So that definitely takes away from your score if you don't pay attention to that part of the rules. Okay, tiers. This event has this concept of tiers as well. And there are 3 tiers. So the first tier it consists of all those bridges that hold a load and meet all the construction parameters and competition requirements. Tier 2 is for bridges that will hold a load, but they violate a construction parameter or a competition requirement. Or in a virtual tournament, if your test apparatus isn't up to snuff. In Virginia, this event will always be an in-person event, so we don't have to worry about that part. And then tier 3 is bridges that are unable to be loaded for some reason. So what do we do with the tiers? Well, the idea is that all the bridges in tier 2 will rank after the bridges in tier 1, even if they have a better score than a bridge in tier 1. And likewise, all the tier 3 bridges will rank after the tier 2 bridges. So, so if you have a bridge that holds a large load, maybe the whole 15,000 grams, and gets the bonus, and it's not very heavy, so you get a great score, but you miss a construction requirement, then you will rank after a bridge that only held the bucket and couldn't hold any sand. So what this means is that you are strongly incentivized to pay attention very closely to those construction parameters and competition requirements. And an example of that we see every year, it's always a little bit heartbreaking, is somebody who reads a rule, like maybe in Division B, the 15 centimeters above the test supports, and they design their bridge for 15 centimeters exactly, but they measure slightly wrong, and it actually comes in at 14.97 centimeters. And then bam, they're down in tier 2, no matter how well they did in holding a load. So in that case, it might be a good idea to maybe design for 15.1 centimeters, exceed the requirement slightly so that you make it easy for the event supervisor to declare that you are within the construction parameters.
So I'm going to break in here. Could we go back to the pictures of the test supports?
This
So
one?
somebody is asking, could you say the 10-centimeter requirement again in B? I think this is a B bridge coach
The
that's
15
asking.
or the 10?
The 10 centimeters. They want to know the 10-centimeter requirement is about width, right?
Yes, so this is a diagram of the top of a test support. You're looking down on it.
Where the bridge will rest.
And the bridge rests on this top. And the requirement is that the bridge in Division B may only rest in this middle 10 centimeters, the crosshatched part, whereas in Division C, the bridge may only touch in these end pieces.
All right. And then just also confirming, could you go back one more? In Division B, the loading block has to be 15 centimeters high, right? Higher than the test support.
Right.
So we have somebody who's conflating the two requirements. The 10 centimeters is about width.
Right.
And the 15 centimeters in Division B is about height.
Right.
Thanks. Okay, let's move on.
Okay. All right, so that was our scoring. Now let's talk a little bit about how do you get started in actual construction. So a useful exercise is to do a little bit of reading. Wikipedia has some nice pages, one on truss bridges in particular. And another good resource for getting started is the Nationals practice bridge. I'm giving that first link there is the event page, the bridge event page on the Virginia SO website, but it has links to other resources, including this Nationals practice bridge. And it's a complete set of plans, designed 100%, and you can just take those plans and use them to build a bridge. And this is great for a first try. It's likely that it's not a winning design because, of course, everybody has this design. So you're going to have to do better than this to win, but it's a great place to start. But I'm actually going to recommend that you start in a different place using a simulation of a truss. And there are a lot of these truss simulators out on the internet, a lot of free ones. And the second link there is a link to one created at Johns Hopkins University. It's a simple, easy place to start. There are, of course, more sophisticated simulators, including 3D ones. I give you a link to one there that has a deal for Science Olympiad students. These typically cost money. They're much more complicated, and they really are not necessary. So I'm not going to talk any about that. I'm going to show that Johns Hopkins University simulator and talk a little bit about what you can do with that. So what this is really good for is building your intuition about how trusses work and what different truss designs do for you. And so you can just very quickly draw many different trusses and then test them out and see how they do and see how they differ. And that will help you to have an intuition about designing a truss. So what you do with this truss simulator is you make a drawing like the one on the left there. These are actual screenshots from that truss simulator. And you start in a little bit of a funny place. You place what they call nodes, which are these little circles with the numbers in them. And those aren't exactly parts of a bridge, right? But they're kind of like the glue joints in your bridge. And then after you place those nodes, you connect them with what they call members, which are the pieces of wood. Okay, or in this drawing, they're the lines. And you build out your bridge like that. You hang a load from, I've got the load on the bottom middle node there. If you were doing this in Division B, you'd want it hanging from the top, of course. And then you push the solve button and it computes forces and shows you the picture on the right. So what is it showing you there? Well, the numbers are showing you the sizes of the forces in each of the members. And the color is showing you whether those forces are compression forces or tension forces. So a compression force is where the ends of the wood are being pushed together. And a tension force is where the ends of the wood are being pulled apart. And this is actually very, very important to pay attention to, whether your force in each member is compression or tension. And the reason for that is that when you have a compressive force, the wood wants to bend. When you have a long, thin piece of wood and you push the ends together, it tries to bend to get out of the way. And then as soon as it bends, that wood will collapse and snap. And that is the most typical way that your bridge will fail. So what do you do about that? Well, the key thing is that the longer and thinner the piece of wood is, and the higher the compression force, the more likely it is to bend. So you can fix that problem in a number of ways. You can redesign the truss so that the size of the force is less. You can use a thicker piece of wood. Of course, that's heavier, but sometimes that's a good option. And then the other option is to subdivide your truss into smaller triangles so that those pieces are shorter and then they are less likely to bend. So yes, we can move on here. So limitations of simulators. It's a good idea to use a simulator for a little bit, build up your intuition, but you don't want to spend a lot of time in a simulator because they have some limitations. And the chief one is that they don't give you practice in construction. And this is really crucial. At the end of the day, you have to actually build a bridge, and accurately cutting and making strong glue joints are nearly as important as the bridge design in the strength of your bridge. And there's no way to get good at this except with hands-on practice. So you want to move out of the simulator and start building bridges fairly quickly. So before we talk about how we actually build the bridge, let's talk about the materials you're going to use. You're only allowed to use two materials, wood and glue. So with respect to the wood, I would recommend that you just use balsa wood. There are lots of kinds of wood out there, of course, but we've found over the years that other kinds don't really work as well. You can find balsa wood online. You can also buy it in a hobby shop or AC Moore or Michaels. I actually like to go to a hobby shop and pick out my own pieces so I can pick the straight pieces and the pieces that don't have flaws in them. But lots of people buy it online. There are a few extra requirements here. You may not use bamboo or reeds. Those are technically not wood. They're actually grass. And you may not use commercially made composites like plywood, particle board, MDF, and so on. You can make your own plywood. You can take several pieces of plain wood and glue them together in layers, and that's what plywood is. That process is called lamination. And you may do that yourself. You just may not buy the wood already laminated as plywood. And then there's you may not have paint or coatings or labels stuck to your wood.
So like if you buy balsa that has a price sticker on it, you
Right.
must take the price sticker off.
Correct. Sometimes they come with a barcode printed and right on the wood, and they do allow you to leave that, but anything else layered on the wood is not allowed. The second material is glue, and there are lots of different kinds of glue, and it's actually quite important to choose a good one. There's a couple different good choices here. One that I like very much is called Carpenter's Wood Glue. Technically, it's polyvinyl acetate or PVA glue. This is very easy to use. It's strong, and it has this property of being a gap-filling glue. So if the ends of your wood don't quite meet up and there's a little gap there, you can fill that gap with PVA glue, and it will still be strong. Even with a gap, it'll be stronger than the wood itself. But it is heavy. So if you use PVA glue, you want to be sparing with the glue. A second excellent choice is cyanoacrylate or CA glue. This is often called super glue. There are many brands of this. Super glue is just one of them. This is very strong. It's very light, but it is not gap filling, which makes it tricky. You have to cut your pieces of wood quite accurately so that the ends meet up and actually touch each other. And the other tricky thing about CA glue is that it sticks to skin very, very well. And I can guarantee you over the course of a Science Olympiad season, you will glue your fingers together, and it is painful to pull them apart. So have either some of the solvent that they sell with CA glue or some acetone on hand so that you can get your fingers back apart. There are a couple of other kinds of glue that I'm just going to skip over because they're really not as successful. And then that last kind of glue there, I do want to mention hot glue. It's a great choice for crafts. It's a terrible choice for bridges. It doesn't stick to wood very well. It's weak and it's super heavy. So just don't use hot glue.
Thank you, Ian. So I think now we're going to be moving on to an actual demonstration of the skills that you use to actually, how do you actually
we're going to convert a little bit here so that we are showing you what's going on the table here.
I'm going to ask people to go ahead and continue submitting your questions, but and we will address them at the end. But obviously, I'm moving now to a phone view so that I can get good pictures of what Ian's doing.
Okay, so this is an example bridge. This is not a good example for this year, but it's an example that I actually have and have plans for. So so I'm going to use it for this demonstration, even though you won't be building a bridge like this. But just so you can see, in a minute, I'm going to show you the plans. So what these plans are lines on a piece of graph paper that represent the members in the bridge, the pieces of wood. So it's as if I just laid this bridge right down and drew a line for each member on the truss. And it's important that when you draw your plans, that you draw them at 1-to-1 scale or full size. You'll see why in just a moment. Now, you'll notice that I've only drawn half of a bridge here. And the reason for that is that there's a cute shortcut you can take where you draw half your bridge and then you scan this to turn it into a picture in your computer. And then you make a copy of the picture that you then flip the other way. Graphics programs always have that function to flip it the other way. And then you can print each one of them and you paste these together and then you get a whole bridge for half the effort, and the two sides of the bridge match exactly. So that's a nifty little shortcut. So once you've got your plans drawn, I use a small bulletin board like this, and I put that on my table, and then I'm going to take my plans and lay them on top, and I take a little bit of care to line up the two halves so that they're aligned with each other, just so. And then I take a piece of wax paper and lay that on top, and that prevents glue from getting on my plans. And then I'm going to take some pins. Spill myself a few pins here. And I'm just going to stick a couple pins in the overlapping section to keep the plans in place. A couple out here so things don't move around on me.
So this wax paper is nice because you're able to reuse the plans then if you decide it was a good design.
That's correct.
Also, somebody earlier asked what goes in the design log, and plans can be a part of the design log. You want to
That's
look in
great.
the rules to see what goes in there, but this is a good resource for that.
Right. So now I'm gonna get some balsa wood here, and what you're going to do is, you're just going to pick one of the members, and you're going to lay the balsa wood right up alongside it like so, and then you're going to cut it. Now, typically we use an X-Acto knife like this. That's a good tool to use to cut it, and you can just cut right on top of the diagram so you get it exactly the right size. If I will say, if you're using thicker, this is thin balsa wood. If you're using thicker balsa wood, it's often a good idea to get this tool, which you can buy at the same place you get X-Acto knives. It's a saw, very, very fine tooth, small saw. And that's good for the thicker balsa wood because it doesn't crush the balsa wood and weaken it. But once you cut it.
And I'm going to interject here that both of these tools are very safe for students of all ages to use. But you might, if you have young ones, you can go ahead and watch them the first time.
Yeah. So I'm not going to actually cut my wood because I don't want to end up with a whole bunch of little scraps that I throw away. But once you've cut it, you lay it right on the line where you want it to be, and then I'm going to pin it. And you'll notice I'm not putting the pins through the wood because that weakens it. I put pins in pairs that go one on either side and hold that wood down. So you're going to want, two pairs on each piece of wood. Sometimes on a longer piece of wood, you might want more. This one is a little on the long side. So you might want another pair of pins in the middle. Okay, so that piece of wood is now secured on there quite well. And now I would get another piece of balsa wood, and let's suppose I'm going to do this piece right here. You will note it may not be easy to see, but the end of that wood is actually beveled a little bit, angled a little bit, so that when I place it on this angle, it will meet up with the member that we pinned before very accurately. And that's always good, but it's especially important if you're using CA glue, because that's not a gap filling glue. So normally I would cut this on the bottom. Again, I'm not going to actually cut it. Now, the procedure here is a little different depending on the glue you're using. If you're going to use PVA glue, you would, at this point, after you've cut this, you would dip your end in a little puddle of PVA glue, and you would stick it on here, line it up, and then pin it in the same way that we pinned the previous one. One more pin here. Okay, but if you're using CA glue, you would actually pin it in exactly the same way, but without putting any glue on it. You would just pin it dry like that. And then after you pin it, you would put a drip of the CA glue, which is very liquid, right on that joint, and the capillary action will pull that drip of glue into the joint, and it will dry in seconds, and make a very strong joint. So that's the difference in the glues.
How long does wood glue take to dry?
Wood glue takes like half an hour to an hour to dry. The CA glue dries in,
Literally seconds. Yeah.
5-10 seconds. That's why you have to put the pieces together before you put the glue on, because you don't have time to get it in place after you drip that glue on there.
Okay.
So you can imagine, if I were to take the time to do this out, I would end up with pieces of wood on all these lines, and it would look like a hedgehog with all the pins sticking out of it. And you would allow the glue to dry, and then you would take all the pins out, and the glue won't stick to the wax paper, so the truss will just come off in one piece.
This is really nice too, because now you're gonna have to do it twice to make two identical sides of the bridge, and then the sides will be identical.
Right, because you're using the same plans each time. So you would do the whole thing a second time to make the second truss, which is the other side of the bridge. And now, just a few words about putting those two together. This is actually a bit of a tricky part of building the bridge, but you can imagine, I've got the truss on this side and the truss on that side. And one method that works fairly well is to use something like bookends, or some largish heavy object, one on each side, that will stand up straight, and then you can put the two trusses up against them, maybe use a little double-sided tape or some string to tie them on there, and then you can put all of the cross pieces in, and glue those together. And that's a little bit tricky to get the two sides assembled like that, but it kind of depends on what objects you've got at home that you can use to hold the trusses up.
You also just get better at it with practice, I think, as well.
Very much so.
This is one of the trickiest pieces, is making the two sides match up.
Right.
Otherwise, the stresses are not as solid on the bridge.
Yes, that is, or even, yeah.
Or even, yeah.
Okay, so that's the basic idea of how you put one of these bridges together. And now let's talk a little bit about testing. I'm gonna do this in two stages. So I'm gonna talk about first about how do we test in a tournament with the official testing setup, and then after that I'm going to talk about how can you do that at home, where you don't have the official testing setup. So, but let's talk about the tournament approach first. So the very first thing that we do at a tournament is to take the mass of the bridge. So we'll use a little scale like this. These are quite accurate to the 100th of a gram, and you want to let it 0, and then you can just put your bridge on there. Oh, come on, 0. Yeah, all right. And weigh that. I think this bridge came in at something like 17 grams or something. And you're going to write that down. And then I set that aside, and the students will then, in a tournament, the students will set up their bridge on a setup like this one. These blocks of wood are the test supports, and you'll notice that there's C here and B in the middle, just like we talked about before. And there's also lines on here that show the clear span. This is a Division C table, so they're 45 centimeters apart. And the students will line these up. I always ask them to make sure that I can see those lines a little bit to make sure that they're actually 45 or the clear span apart.
Now, the students do that themselves, and they're
That's
also
right.
lining up this middle line
Right.
with the middle line as well, or roughly, so that
And-
it's happening in the center of
And
the,
our event supervisor will help them get all of those things right as they set this up.
Okay.
And then they're going to set the bridge across. Now, this bridge, as I said, it's not
it's not
designed
legal.
for this year, and it's not long enough. So I'm going to pretend that the clear span is less, just so I can show this setup. But the students would put their bridge across like so, and then they place the loading block. So this is a loading block. It has an eye through it. Okay, it is 5 centimeters square, and then a couple centimeters thick. The thickness is not as important as the 5 centimeters square. And they're going to set that in the case of Division B, it'll go on top like this. And then they put an S hook. All this hardware was easily purchased at Home Depot, by the way. And they put a chain on here. And then I have a second S hook that I'm going to hang down below to hang the bucket. So we're going to duck down below here. And we're going to put this S hook. Well, yeah, so a lot of students will
They think the
put
S
it-
hook has to go down at the
they'll
bottom.
put the S hook maybe at the bottom of the chain or too low like this, but you'll see if I put it at this height, it won't even hold the bucket up. We actually want the S hook to be up quite high so that when you hang the bucket is actually a little ways off the floor. And the reason for that is that some bridges will bend a little bit, and you don't want the bucket to touch the floor, because your test ends when it touches the floor, whether the bridge broke or not.
Right, and if your bridge is bending, then you really don't want it to be too close to the floor, because it might still be able to support the weight, but if, the bucket touches the floor,
exactly.
you're hosed.
Exactly.
Okay.
So, okay. So once they get that all set up, they'll typically adjust the bridge a little bit, and then you think you're ready to load sand, but you're not. You must put on your safety glasses. And your partner should also put on safety glasses. And anybody who is in the vicinity should put on safety glasses, because when these bridges break, they throw little pieces of wood at very high speed. And if that goes in your eye, it can do quite a bit of damage. So it's very, very important that you always wear the safety glasses when you are loading your bridge. So
Even in practice.
even in practice, yeah.
And,
So-
and that would be true, parents. It's a great idea to film bridges breaking,
Yes.
right? And then you can kind of run them back in slow-mo, see where, and as you do that in slow-mo, you'll see where the bridge is bending, you'll see where it, exactly what the stresses were. But if you're getting close enough to film, you need the safety goggles too.
Right. Okay, so it usually 2 people work on loading a bridge, and one of them, who would sit on the other side, stabilizes the bucket so it does not swing. That's actually quite important, because when the bucket swings, it puts sideways forces on the bridge that you don't want. So we have these sticks with the little spring ends, and you just touch the ends to the bucket to prevent it from swinging. At home, you don't need sticks like this. At home, the stabilizing person can just use fingertips to touch the bucket and stop it from swinging. You don't want to hold the bucket up, of course, but you can just touch it with your fingertips. And then the other person is going to load the bridge. So I'm going to pour some sand in here, and you would just keep pouring until the bridge breaks. And now you'll notice something here, that I've poured the sand in asymmetrically, so the bucket is actually hanging at an angle. That's actually not a problem, because even when it's at an angle, it will still move so that the force is straight down, even if the bucket's at an angle. But
So
you
that's
just want
not one of those sideways forces you're worried about,
right. But what you don't want is for the bucket to be swinging.
which it is slightly, because we don't have somebody using the
Yeah.
steps.
Okay.
All right.
So you would, in competition, you would continue loading until it breaks. And then when it breaks, then what we have to do is measure the load. So to do that, you take this bucket out. We would, if there's some pieces of the bridge that landed in the sand, we would take those out. That's often the case. And then we would take the S-hooks, the chain, and the loading block and put those all in the bucket.
So that's part of the load too.
Because that's part of the load too. And then we weigh them on a scale like this one here. At home, you can use a bathroom scale. They're not very accurate, but they're good enough for home testing. We use a much more accurate scale like this. And we weigh that.
All right, so Ian, can you tell us I mean, this is elaborate. This is the testing setup they'll see at Vassar tournaments. What's what can people do to set up a quick and easy test?
Right.
setup?
So there's several aspects to setting up your own setup at home. The hardware, as I said, is easily purchased, and the bucket are easily, and the sand are things you can all get at Home Depot or Lowe's. But you will need to make a loading block.
This is the trickiest part, I think, really, right?
Yeah, it really is. If the easiest way to do this is if you can find somebody who has a table saw or a similar power saw to accurately cut a 5-centimeter square out of a piece of scrap wood. And of course, lots of people don't have a table saw, but remember that this part does not have to be built by the students. And so any, on a 15-student team, it's likely that one of the parents has a saw like that, or you could go talk to your technology teacher at school and see if they could do this for you. But if you have a saw like that, this is very, very easy to do. And then I'm just going to take the eye bolt out so you can see. You're also going to drill a hole in the middle of that, and then you just put your eye bolt through there.
And the dimensions for the eye bolt are also given in the rules.
That's right.
One thing I wanted to note, every year we see teams come with loading blocks glued to their bridges. You don't bring the loading block. We provide all the testing equipment. You're just bringing the bridge. And that typically makes an illegal bridge.
Right.
You have to use our loading blocks that don't come with just practice with your own, but don't come with it attached to your bridge.
Right. Okay. So the next part of a home testing setup is the table itself. Of course, you don't want to buy one of these fancy tables, but there's a couple of ways you can imitate a table like this very easily. So one way is if you have a couple of tables at home that are the same height, you can just position them to be approximately the size of this. The exact size of this hole is not important. So just, set them to be about the right width, and then have your bridge go across from one to the other.
Well, you'll put test blocks. You'll put the test stand
We'll
down
talk
first,
about
but
the test blocks in a minute. Yeah. A slightly more sophisticated way to do it is if you have somebody who's a little handy and you have some scrap plywood, you can have a piece of plywood like this and cut a hole out. This hole's probably a little too big, but
I think it's okay in this dimension, too long in that one.
but it doesn't have to be exactly square. The size of this hole, the rules even say approximately 20 centimeters square. So, just any way that you can get a hole about the right size. And then you can take this and put it across 2 tables or 2 chairs and
2
test on
sawhorses.
that, or 2 sawhorses, right? So that makes an easy way to build a table quite inexpensively. And then the last part of your setup is these test supports. Now, they're 1.5 inches tall, 1.5 inches wide, and 6 inches long. But you can actually get away without having something that's exactly like that. There's a couple of ways to do that. Some folks that have a table like this, like if their school has that table, they come with blocks like this. The ones that they come with are typically a little bit too tall. But that's actually not as big of a problem as you would think. In Division B, the exact height of these blocks does not matter because the whole bridge has to be above them, and it doesn't really matter whether it's 2 inches off the test base or 6 inches off the test base. It just doesn't really change the situation. In Division C, that can matter because, of course, your bridge can dip down, rests on the top here, but it can dip down and be closer to the tabletop. And if you built on large ones like this, you might fool yourself into thinking that the bridge doesn't dip down too far, but it really does. You can use test supports that are too large, even so, as long as you're careful about measuring how far it dips down. That's one way to solve that problem. Well, we'll talk about another way in just a moment. Another approach that you can use for these is
actually, I'm going to interject here that you can also buy. There are metal bars that are the exact size for this year. You can buy online as well.
Right. Those hollow aluminum square shapes are available online. It's a little expensive, but another thing you could do is just use a 2x4 like this. And like I was saying, in Division B, the fact that it's way too tall just doesn't matter. In Division C, again, if you have somebody with a table saw, it's not very hard to rotate this like this and cut this to be the 1.5 inch height if you really want something that's exactly the right height. Or, as I was saying before, you just be careful about how you measure.
But it's important if you use any of these substitutes, again, to be very careful about the measurements of what's on top of the block.
Right.
Both B and C.
Yes, you're going to want to put the lines on the center line on top and measure those pretty carefully so that your bridge sits in the right place. Okay, so that is all you need to set up to test at home. It's not very hard to do this.
So let's bring the computer and everything back over. We're going to take one last look at the chat and see what kinds of questions we might have.
Sure.
All right, so I'm looking through. We've got a question about the potential maximum length of a bridge. This person was particularly concerned about in Division B.
Sure. So there really is no maximum length of the bridge, and the rules just simply don't say anything about the maximum length. But keep in mind that if your bridge is longer than it needs to be to go across that clear span and sit on top of the test supports, that you're just adding weight to it. So you want, it has to go across the 35 centimeter gap in Division B or 45 centimeter gap in Division C, and then go a little farther to be on top of the test supports. But you don't want it to go much more than that because you're just adding unnecessary weight.
Thank you, Ian. All right, we wanted to make sure, again, everybody's trying very carefully to make sure that they understand the width requirement and what the top of the block looks like, or the test stands look like. So this person says they want to make sure they understand the rule correctly for Division C. On the contact piece, the test stand, the Division C bridge will not touch the contact piece all the way across. It can only touch the contact piece in those two areas labeled C.
That is correct. That is correct. Only on the ends, in the end zones, so to speak.
And the B bridge, if it touches inside that area, it can't also touch outside of it.
That is correct. The B bridge may only touch in that middle 10 centimeter area.
Somebody wants to know if the students will stop loading sand at 15 kilograms. How is that known or understood?
A good question. The event supervisor measures out a certain amount of sand that is a little bit more than 15 kilograms before the students start loading, and then students will just load sand until they use all of that sand, and then they're sure at that point that they have actually exceeded the 15 kilograms, but not by much. It's usually 1 or 200 extra grams of sand.
Thank you, Ian. Are there any other questions anybody would like to put into the chat or ask? Give it just a minute here. Are there any bridge designs that you would recommend?
Well, so I actually don't like to recommend any particular bridge design, because that's kind of the point of the event, and the fun of the event is to innovate and come up with interesting designs. But if you look on the Wikipedia Trust page, you'll get a bunch of ideas. And online, there are especially on the national website, there are some interesting ideas there too.
Keeping a good log, a record of what works and doesn't work. If your bridge holds 15 kilograms and it was a good design, then actually maybe the thing you want to do is keep the design, but see if you can make it lighter, put fewer triangles in,
use thinner wood.
Or use thinner wood and try it. So once you've got
Yeah.
a bridge that holds 15 kilograms, because with the bonus, you are somewhat incentivized to try
Right.
to hold 15 kilograms. But if you can hold it, and if you can hold a lot more than that, I mean, then maybe the bridge is too heavy.
Right.
So you can go the other direction.
That's correct.
At a Division B level, somebody says, is this more of a build event than a design event?
That's an interesting question. It's really kind of 50-50. I mean, you need a reasonably good design to do well, but you also need to learn how to build well. You need to be able to cut accurately and make strong glue joints and so on. So it's really both build and design event at either level, actually.
Yes, indeed. Anybody else have any questions? I don't see any. Ian, thank
Okay.
you so very much for your time.
Sure.
We appreciate. When is the tournament? You need to talk to your coach about that, because there are several of them. You need to figure out which team you're on and when you're going to tournament. So thank you for everybody's time. Thank you, Ian, and we will put this recording up probably later today.
And we'll see you at regionals.
Indeed, we will.